Good day everyone, here's our math challenge for today. And here's our question. If x, y, and z are non-zero, what is the minimum value of the expression x to the fourth plus z squared minus 4yz plus 4y squared minus 4x squared y plus 2x squared z minus 2? Now, if you want to try this problem, just pause this video and we have 15 seconds to do that. Timer starts now. Alright, time's up. Now, here's my hint to you. So the hint is to use factoring. Now, let's answer this question together. So, let's focus on the given expression. We have x to the fourth plus z squared minus 4yz plus 4y squared minus 4x squared y plus 2x squared z minus 2. One thing I notice here is these three terms with an even exponent. So we have x to the fourth plus 4y squared plus z squared. Now take a look at x to the fourth power. This can be written as x squared raised to 2. And this 4y squared can be written as 2y raised to 2. And of course, z squared is z raised to 2. Now this reminds me of the expansion of a plus b plus c quantity squared. Because if we expand a plus b plus c quantity squared, we get a squared plus b squared plus c squared plus 2 times ab plus 2 times ac plus 2 times bc. Now notice that a can be x squared, b can be 2y, and c can be z. Thus, maybe this expression below can be written in the form of x squared plus 2y plus z quantity squared. Now, let's expand this expression. We have x squared plus 2y plus z quantity squared. If we do that, we get x to the fourth power plus 4y squared plus z squared plus 2x squared z plus 4x squared y plus 4yz. Now, take note that this x to the fourth power is the same thing as x squared raised to 2. This 4y squared is the same thing as 2y raised to 2. And this c squared, of course, is the same thing as z squared. And now, here's the thing. This 2x squared z is the same thing as 2x squared z right here. But this 4x squared y, we have a positive right here. And on our original expression, we have negative 4x squared y. Also, we have positive 4yz here. And on the bottom part, in our original expression, we have negative 4yz. Now, also take note that those two terms contains a factor of y. Now, this tells us that the sign of 2y is not positive. Maybe this is negative 2y. So, we have x squared minus 2y plus z quantity squared. Now, let's see what will happen if we expand x squared minus 2y plus z quantity squared. If we do that, we get x to the fourth power plus 4y squared plus z squared minus 4x squared y. We have minus 4x squared y plus 2x squared z. We have 2x squared z right here. And minus 4yz, and we have also negative 4yz. Therefore, this expression right here is equivalent to x squared minus 2y plus z quantity squared. It follows that our original expression can be written as x squared minus 2y plus z quantity squared minus 2. So, we have now x squared minus 2y plus z quantity squared minus 2. And don't forget our goal. Our goal is to find the minimum value of this expression. And now, we know that this expression, x squared minus 2y plus z quantity squared, will always greater than or equal to 0. Why? Because whatever happens, whatever value of this number inside the parentheses and we squared it, it becomes positive. Now since we want the minimum value of this expression, therefore this expression inside the parentheses must be equal to 0. For example, x is 1, y is 1, and z is 1. So this expression must be 1 minus 2 plus 1, or simply 0. And 0 raised to 2 will give us 0. So the minimum value of this expression right here is 0. Thus, the minimum value of this expression must be negative 2. This will happen if the square number must be 0. Thus, if x, y, z are non-zero, then the minimum value of this expression, x to the fourth plus z squared minus 4yz plus 4y squared minus 4x squared y plus 2x squared z minus 2 must be negative 2. And as always, we're done.